Hello friends. Some time ago, when replacing one of the humidifiers, which unfortunately have a certain service life, I decided to review and update the control logic that I had written several years ago. There is a video tutorial on this topic on my channel. First, I reviewed ready-made integration options for this task and realized that none of them fully suited me. They did not include all the conditions I needed, there was not enough flexibility, and so on. So I followed my usual path, to write my own logic tailored to my needs, implementing exactly what I required. This tutorial will be useful for those who prefer to solve such tasks independently without searching for and adapting ready-made solutions, which is often a more labor-intensive task. In addition, you may find something useful for yourself. Share your thoughts and developments, constructive criticism, and suggestions. I will be glad to receive all informative comments. Before we begin, by tradition, I ask you to like this video. It will help other people interested in the smart home topic to find it, and subscribe to my channel if you have not done so before. For this case, the most ordinary air humidifier is used, most often ultrasonic, without any interfaces or external control, except manual. Even models that are controlled by a remote are not suitable. They require slightly different logic and a controller for sending IR signals. The models that suit us are those where all control is carried out with a single rotary knob. It handles turning on and off as well as setting the intensity. Once you set the appropriate position, usually something in the middle, so that the intensity is sufficient to change the humidity level in the room and at the same time there are no puddles. After that, all control will be through a smart plug with energy monitoring on which one of the metrics used in this logic is based. If we talk about a specific model, here I use a non-smart version from the Xiaomi ecosystem, Media. I will leave a link to it in the description under the video. During sales, which take place quite often, it can be purchased at a very attractive price. Why did I choose this model? Not least because of the brand, which provides good quality at a relatively low price, but mainly because of the tank volume and design. The volume is 4 liters, which is enough for quite a long time. And the design allows you to refill water directly during operation, simply by removing the lid. Whereas most models require turning off the device, removing the tank, and filling it with water through a lid located on its bottom side, which often opens quite tightly. Here everything is much more convenient and significantly faster. Now let us move on to the logic and how it looks in the interface. You can see it here on the right. In addition to the humidifier, a smart plug with energy monitoring is used, as well as temperature and humidity sensors and opening sensors that allow tracking ventilation moments. Everything else consists of logical entities. And now I will explain everything in detail. As always, all the logic is written in a single package file. You will find the link to it in the description under the video. This approach allows you to quickly find all the necessary objects, which are not scattered across different interface pages, make changes, copy and move them to other packages, and also use it entirely, only changing the entity names to your own. In my opinion, there is no more convenient way to organize logic. So let us begin. I will go from the start and explain and show all the code blocks in detail. I began with 2 date and time input entities. They are intended to allow setting the humidifier's operating time directly in the interface. I only need the time, so I disabled the date. Here are these entities in my interface. As you may have noticed, this is the live interface of my working server, that is, an absolutely working case that I am currently using. Next, in the package I have described 2 input Boolean entities. These are logical switches that have 2 states, on and off, and can be controlled both manually from the interface and from automations. They are convenient to use as software blocks, as in this case. The first is the humidification mode switch. If it is turned off, then all this logic does not work. This is more convenient and faster than manually disabling all automations. The second is a safety lock that will trigger if the water runs out. It will block the main automation until you refill the water. Here they are in the interface. The operating mode is the very first one, and it has only manual control from here. You decide yourself when you need to start and when to turn off the humidification mode. The safety lock is controlled by automations, It could have been omitted from the interface entirely. I included it only for demonstration purposes. Next, there are 3 entities for numeric input. I use the principle of flexible adjustment so that everything can be configured in the interface without changing the code itself. The first is setting the target humidity, the desired limit to be achieved. I set the range from 30 to 60 with a step of 1. The second is hysteresis, the humidity range relative to the target, at which the humidifier will turn on and off. For example, with a target humidity of 50% and hysteresis of 3%, it will turn off at an actual value of 53% and turn on at 47%. The third is setting the minimum power on the plug, below which the system will consider that the water has run out. This is how they look in the interface. The power is determined experimentally. In my case, the normal power of the humidifier operating in the mode I set is 12 to 13 watts. When the water runs out, it turns off and the power drops to 0 while the plug remains on. For the logic, it is important to distinguish whether this is a shutdown due to reaching the threshold or because the water has run out. That is why the safety lock was added. Here we also set the desired humidity value, and hysteresis is needed so that the humidifier does not constantly turn on and off when reaching and dropping below a fixed threshold value, the so-called debounce effect. Now the actual logic begins, starting with binary template sensors. The first one I called ventilation. It monitors the status of 2 opening sensors, but you can add more sensors to this logic in the same way, logical or is used here. If any one or both at once of the opening sensors are triggered, the ventilation sensor will turn on, during which the humidifier will be turned off. For the previously mentioned debounce, a 30-second delay for turning on and off is set here. These entities are displayed in my interface in the left column. We see both the ventilation sensor and the window and door sensors, 2 of which are monitored by the template. In the right column, it is simply duplicated for completeness of the picture. The next binary sensor is intended to determine the humidifier's operating period and is built based on the previously mentioned time input entities. It can have 2 states, on and off. The start time in this template is by the variable S, the end time by E, the current time by N. It will turn on under the following conditions. If it is impossible to determine the start or end time, then we consider that operation is allowed. If the start time is less than the end time, then within the interval between them using logical and. Otherwise, for example, when the period spans the start of a new day, using logical or, that is, fulfillment of only one of the conditions. Here is this sensor in the interface. Currently, the time corresponds to the conditions, so it is active and allows the automation to run. The second template is needed to register the event that the actual power is lower than the threshold we set for detecting the absence of water. Delays for turning on and off are also set here to avoid false triggers. For example, when the automation has just turned on the humidifier, but the power has not yet updated. At the moment, the actual power exceeds the threshold, so the water presence sensor is active and the logic operates normally. And we have 2 final template sensors left, no longer binary, but regular ones that can take any values. The first contains the current humidity value and is built based on data from 2 sensors at once. If necessary, more can be added. 2 goals are achieved here: measuring humidity at several points and obtaining an averaged value, and, in case one of the sensors goes offline, the automation will operate based on the readings of the other. First, we assign the actual values of the physical sensors to variables S1 and S2. It is not advisable to specify a data type here, for example a floating point number, so as not to break the logic. Instead, a check is created using variables v1_ok and v2_ok, which will receive the status false if the corresponding value S1 and/or S2 is returned as unknown, unavailable, or none, and also if the conversion to a number fails. If these variables contain normal numeric values, then the variables will receive the status true. Depending on this, the further actions are either to take the average value of the 2 sensors or to select only the one that is alive. Here it is in the interface. Currently its value is 45.4%, and all the humidification automation logic operates based on it. The second sensor is not needed directly for the logic. It is not used in the automations. It was created only for the interface so that possible errors can be diagnosed. The beginning of the template is identical to the previous one, but after checking the validity of the humidity values, the sensor takes the value average if there is data from both sensors, or displays which sensor is alive and used for the logic. It is displayed in the interface so that any issue can be identified in time if one of the sensors is not working. If desired, a separate automation could be created for it to send a notification, but within the scope of this case, I did not implement one. Now let us move directly to the automations. They implement the remaining part of the logic based on the objects I created earlier. This is the main working automation, whose trigger can be anything that may influence the decision to turn the humidifier on or off. These include the humidity sensor based on two physical sensors, the entities for setting the target humidity and hysteresis values, the operating mode switch, and the ventilation and allowed time sensors. In addition, there is a trigger here that runs the automation every 5 minutes. This is also an additional check for abnormal situations. For simplicity, I also use variables here, so that I do not have to remember what is what later. I had a large number of comments. This takes some time, but saves it later. The variables are assigned the plug entity name, the humidity value, the on and off thresholds, respectively. This is the target humidity minus hysteresis and the target humidity plus hysteresis. In addition, there is a variable that will be active when the plug is on. There is only one condition here. This is a feature of my configuration, the server operating mode switch that shows which one is currently active. Instead of it, you could, for example, use a power availability sensor. If there is no power, then the automations do not need to run. Next comes the condition selector. The first one handles turning off the humidifier if the plug is on, and at least one of the blocking conditions is met. The humidification mode is off, the ventilation sensor is active, the time sensor is off, or the humidity is equal to or higher than the shutdown threshold. Similarly, the second block handles turning on the humidifier, checking that all enabling conditions are met at the same time. The plug is off, the humidification mode is active, the ventilation sensor is off, the time sensor is on, the low water safety lock is off. We will get to it shortly, and the humidity is less than or equal to the lower threshold. This automation is a control one. It is used to track that the water has run out. As a trigger, it uses a change in the binary sensor that is active if the current power is above the threshold and off if it is below, as well as every 5 minutes. In the previous automation, this sensor does not participate and does not affect its logic in any way. This was done intentionally. There are several conditions here. I already mentioned the first one, the server operating mode, a feature of my configuration. The second checks that the plug has been operating for at least 2 minutes. This filters out possible errors when turning on the humidifier. The third, the power sensor must be off, meaning the actual power is below the threshold. The fourth, the logical safety lock must be off. This prevents possible repeated triggers. There are 3 actions here. We turn off the plug, then turn on the safety lock, which will prevent the main automation from turning on the humidifier, and send a notification to Telegram so that you can respond and refill the water. And the third automation is for removing the lock. After the water is refilled and the plug is turned on manually, the humidifier reaches its normal operating power, the sensor turns on, and the lock is removed. I tried to foresee everything. This logic has been working for me for a couple of weeks at the time this video was released, and so far everything is correct. As I said, write your thoughts and suggestions in the comments. Instead of a conclusion, a demonstration of how it works. This is the normal working mode. Let us change the operating time range. This immediately leads to the humidifier being turned off by the working time sensor. We return it back, and the humidifier immediately turns on. Let us change the target humidity. Shutdown by the upper threshold will trigger. Set it to 48%. This is less than the current humidity plus 3% hysteresis. The humidifier does not turn on. We raise the level further, and activation by the lower threshold works. Now we raise the power threshold above the current value. But right now nothing will happen because the plug has been operating for less than 2 minutes. I will not make you wait. Let us move directly to the trigger. This fragment was recorded a few minutes later. We raise the power threshold and wait 30 seconds, which I will speed up here. At this moment, the sensor turns off, along with it the humidifier, and the startup lock is activated. I return the value as it was and turn on the plug manually, as it would be after refilling the water. The 30-second sensor activation delay works to prevent false triggers. During this time, neither the main nor the blocking automation will operate. After 30 seconds, the lock is removed. That is all. I hope this video was useful and interesting for you. I will be waiting for your thoughts and suggestions in the comments. If you liked the video, give it a like and subscribe to my channel so you do not miss new reviews and tutorials. In the description under the video, you will find all the necessary links to this humidifier, to the text file with the package, as well as my Telegram channels and social networks, and the group for smart home discussions. Thank you for your attention. See you next time. Peace to everyone.